The universe doesn't want you to know this. I know that sounds dramatic, like clickbait, like some conspiracy theory. But hear me out. After decades of studying cosmology, quantum mechanics, and the fundamental structure of reality, I've come to understand something profound, something that changes everything about how we think about existence. The universe is hiding something from us, not intentionally, not maliciously, but structurally. There are truths about reality that are systematically concealed from observers like us, built into the very fabric of space-time. And today I am going to tell you what those truths are and why the universe keeps them hidden. Let me start with something simple. Information. We think we can know things about the universe. We think if we look carefully enough, measure precisely enough, we can discover what is really out there. But there are fundamental limits to what we can know. Limits that aren't about our technology or our intelligence. They're built into the laws of physics themselves. The universe doesn't want us to know everything. It can't let us know everything, and understanding why reveals something deep about the nature of reality. Think about the speed of light. We usually think of it as just a speed limit, the fastest anything can travel, but it is more than that. It is an information limit. Information cannot travel faster than light. This means there are parts of the universe we can never know about. Right now, as I am speaking, there are galaxies so far away that light from them hasn't reached us yet. These galaxies exist. They're real, but we can't see them. We can't know anything about them. The information about their existence hasn't had time to reach us, and it gets worse. The universe is expanding. Not just expanding, but accelerating. Distant galaxies are moving away from us faster and faster. Eventually, galaxies will be moving away from us faster than light can travel between us. Not because they're moving through space faster than light, that is still impossible, but because the space between us is expanding so fast that light can never bridge the gap. These galaxies will disappear from view forever. The information about them will be lost to us. The universe will hide them behind an expanding horizon. They'll still exist, but we'll never be able to know about them. The universe doesn't want us to see them. This is our cosmic horizon. There is a boundary beyond which we can never see, never know, never access information. The universe is bigger than what we can observe. How much bigger? We don't know. We can't know. The universe is hiding its full size from us, and this isn't temporary. This isn't something better telescopes will fix. This is fundamental. The structure of space-time itself ensures that we can never know the full extent of reality. But let me tell you about something even stranger. Black holes. When something falls into a black hole, it crosses the event horizon and disappears from view. From our perspective outside, we can never see what happens inside. The information is hidden behind the horizon forever. We can throw books, computers, entire libraries into a black hole, and all that information vanishes from the observable universe. The universe doesn't want us to know what is inside black holes now. You might think the information is still there, just hidden, and you'd be right to think that, but here is where it gets weird. Stephen Hawking discovered that black holes evaporate. They emit radiation, Hawking radiation, and slowly shrink until they disappear completely. When the black hole evaporates, what happens to all the information that fell in? Does it come back out in the radiation? If it does, that violates quantum mechanics, because the radiation appears to be purely thermal, random, containing no information. If it doesn't come back out, that also violates quantum mechanics, because information cannot be destroyed. This is the black hole information paradox. The universe seems to be forcing us into a contradiction. Either information is destroyed, which shouldn't be possible, or information is hidden in thermal radiation in a way we don't understand. Either way, the universe is concealing something fundamental from us. The resolution, I think, involves the holographic principle. The information isn't really inside the black hole, it is encoded on the event horizon, the surface. And it does come back out in the radiation, but in such a scrambled, encoded way that we can't read it. The universe isn't destroying information, but it is encrypting it, hiding it in plain sight. Let me tell you about another secret the universe keeps: quantum mechanics. At the quantum level, particles don't have definite properties until you measure them. An electron doesn't have a definite position until you measure its position. It is in a superposition of many positions at once. This is weird enough, but here is the kicker. You can never know both the position and momentum of a particle with perfect precision. This is Heisenberg's uncertainty principle. The more precisely you know where something is, the less precisely you can know how fast it is moving. And vice versa. This isn't about measurement error. This isn't about clumsy instruments. This is fundamental. The universe doesn't allow certain combinations of information to exist. You cannot know everything about a quantum system. The universe enforces ignorance. Why? Because if you could know position and momentum perfectly, you could predict the future with perfect accuracy, you could know everything that will happen. The universe doesn't want that. Uncertainty is built in. Randomness is fundamental. The universe hides its future from us, but it goes deeper, quantum entanglement. When two particles are entangled, measuring one instantly affects the other, no matter how far apart they are. Einstein hated this. He called it spooky action at a distance. It seems like information is traveling faster than light, but it is not. You can't use entanglement to send information faster than light. The universe has structured quantum mechanics very carefully to prevent this. You can have these spooky correlations, but you can't use them to communicate. The universe gives us this weird phenomenon, but hides its potential for faster-than-light communication. It is like the universe is teasing us, showing us something amazing, but keeping the really useful stuff locked away. Let me tell you about vacuum energy empty space. The vacuum is not empty. It is full of quantum fluctuations, virtual particles popping in and out of existence. This vacuum energy should have enormous effects on the universe. When we calculate how much energy the vacuum should have based on quantum field theory, we get a number that is 10 to the power of 120 times bigger than what we observe. This is the worst prediction in the history of physics, off by 120 orders of magnitude. Why is the vacuum energy so much smaller than it should be? We don't know. The universe is hiding something from us. Something is canceling out almost all of the vacuum energy, leaving just a tiny bit. What is doing the canceling? We have no idea. This is the cosmological constant problem. The universe has arranged things in a way we don't understand to make the vacuum energy much smaller than expected. And it is not telling us how now. Let me tell you about dark matter and dark energy. We've discovered that ordinary matter, the stuff we're made of, atoms, molecules, everything we can see, is only about 5% of the universe. About 27% is dark matter, invisible matter that we can only detect through its gravitational effects. And about 68% is dark energy, a mysterious force causing the universe to expand faster and faster. 95% of the universe is made of stuff we can't see, can't touch, can't directly detect. The universe is mostly hidden from us. We're living in a tiny visible sliver of reality, surrounded by invisible darkness. What is dark matter? We don't know. What is dark energy? We don't know. These are the dominant components of the universe, and they're complete mysteries. The universe doesn't want us to see them directly. They reveal themselves only through indirect effects, through gravity, through the expansion of space. The universe is built mostly from invisible components, and we're forced to infer their existence from subtle clues. The universe is concealing its true nature. Let me tell you about the beginning, the Big Bang. We can trace the universe back to a fraction of a second after it began. We have a detailed picture of how the universe evolved from that early time. But what happened at the very beginning, at time zero, we don't know. Our equations break down, general relativity fails. Quantum mechanics isn't enough. We need a theory of quantum gravity, and we don't have one. The universe is hiding its own origin from us. The very first moment, the moment of creation, is concealed behind a wall of mathematical singularity and before the Big Bang. Did anything exist before? We don't know. Maybe time itself began at the Big Bang. Maybe asking what came before is meaningless, like asking what is north of the North Pole, or maybe there was something before a previous universe, a multiverse something, but we can't see it. The Big Bang wipes out all information about what came before. The universe has erased its own past. We can't know where we came from. The universe doesn't want us to know its history. Let me tell you about the arrow of time. Time flows in one direction. The past is fixed. The future is open. We remember the past but not the future. Entropy increases. Disorder grows. This is the second law of thermodynamics. But why? The fundamental laws of physics are time-symmetric. They work the same forwards and backwards. There is nothing in the equations that says time must flow in one direction, yet it does. Why? The answer has to do with the initial conditions of the universe. The Big Bang started in a very low entropy state, very ordered, very special, and entropy has been increasing ever since. But why did the universe start in such a special state? We don't know. This is another mystery the universe keeps from us. The arrow of time, one of the most basic features of our experience, depends on initial conditions we don't understand. The universe arranged things at the beginning in a very particular way, and it is not telling us why. Let me tell you about consciousness. You are conscious right now. You are aware, experiencing, thinking. How does this happen? How does a collection of atoms, neurons firing in your brain give rise to subjective experience? We don't know. This is the hard problem of consciousness. We can study the brain, we can map neural activity, we can correlate brain states with mental states, but we can't explain why there is something it is like to be you. Why aren't you just a mindless robot processing information without any inner experience? The universe has arranged matter in such a way that it becomes conscious, but it is not telling us how. Consciousness is one of the most fundamental features of our existence, and it is a complete mystery. Is consciousness fundamental? Is it emergent? Is it an illusion? We don't know. The universe is hiding the nature of consciousness from us. We can't even agree on what it is, let alone explain it. Let me tell you about fine-tuning. The fundamental constants of nature, things like the strength of gravity, the mass of the electron, the speed of light, these constants have very specific values, and if they were even slightly different, the universe would be completely different. Stars wouldn't form. Atoms wouldn't be stable. Life couldn't exist. The universe seems to be fine-tuned for our existence. Why? Why do the constants have exactly the values they have? We don't know. Maybe there is a multiverse, infinite universes with different constants, and we just happen to be in one where the constants allow life. Maybe there is some deeper principle that fixes the constants. Maybe it is just luck. We don't know. The universe has set its fundamental parameters in a very specific way, and it is not telling us why. The values of the constants are hidden behind the curtain of initial conditions. Let me tell you about locality. We think of space as fundamental. Things exist at locations. Events happen at points in space-time. But quantum mechanics and the holographic principle suggest that space might be emergent, not fundamental. Space might be an illusion arising from more fundamental, non-spatial information. If that is true, then locality is an illusion too. Things aren't really at locations. Location is just a convenient way of organizing information, but we can't access the fundamental non-spatial reality directly. We're embedded in emergent space. The universe shows us space, but hides the underlying reality. We see the projection, but not the projector. Space might be like a hologram, and we're stuck inside it, unable to see the two-dimensional surface that encodes everything. The universe conceals its fundamental non-spatial nature behind the illusion of three-dimensional space. Let me tell you about determinism and free will. Is the future determined by the present? Do the laws of physics fix everything that will happen, or is there genuine randomness? Genuine openness. Classical physics is deterministic. If you know the positions and velocities of all particles, you can predict the future perfectly, but quantum mechanics is random. Measurement outcomes are genuinely unpredictable. Does this mean we have free will? Or are our choices just random quantum fluctuations? The universe isn't telling us. We can't determine whether we have free will or not. We feel like we make choices. But maybe that is an illusion. Maybe everything is determined by quantum randomness and prior conditions, or maybe there is something more. Something beyond physics. The universe keeps the answer hidden. We can't know if we're truly free or just complicated machines following the laws of physics. Let me tell you about the measurement problem. Quantum systems are in superpositions until measured. But what counts as a measurement? When does the superposition collapse into a definite outcome? Is it when a conscious observer looks? Is it when the system interacts with a large environment? Is it never, with all possibilities existing in parallel universes? We don't know. This is the measurement problem. Different interpretations of quantum mechanics give different answers. Many worlds says all outcomes happen in parallel branches. Copenhagen says measurement collapses the wave function. Pilot wave theory says there are hidden variables guiding everything. We can't tell which interpretation is correct. They all make the same predictions for experiments we can actually do. The universe has arranged quantum mechanics so that we can use it, calculate with it, make predictions, but we can't see what is really happening underneath. The mechanism is hidden. Let me tell you about the Planck scale. At incredibly small distances, around 10 to the power of minus 35 meters, quantum effects and gravitational effects become equally important. This is the Planck length. At this scale, our current theories break down. We need quantum gravity, a theory that unifies quantum mechanics and general relativity. But we don't have one. The universe operates at the Planck scale, but it is not showing us how. We can't probe these distances directly. Our particle accelerators aren't powerful enough. We can only speculate. Theorize, guess, string theory, loop quantum gravity, other approaches. We don't know which is right. The universe is hiding its fundamental structure. At the smallest scales, we can see the large-scale picture and the quantum picture, but not how they connect. The junction is concealed. Let me tell you about infinity. Is the universe infinite? Does space go on forever? Are there infinitely many stars, infinitely many galaxies? We don't know. We can only see a finite region, our observable universe. Beyond that, we don't know. Maybe space is infinite. Maybe it is finite but unbounded, curved back on itself like the surface of a sphere. We can't tell the universe is hiding its global structure from us. We're like ants on a balloon, unable to see whether the balloon is finite or infinite. And if the universe is infinite, then everything possible happens infinitely, many times. There are infinitely many copies of you, infinitely many versions of Earth. This raises bizarre questions about identity, probability, meaning, but we can't know if it is true. The universe keeps its infinity hidden from us. Let me bring this all together. The universe doesn't want you to know certain things, not because it is sentient or malicious, but because the laws of physics systematically conceal information. We have cosmic horizons that hide distant regions. We have event horizons that hide black hole interiors. We have quantum uncertainty that hides precise states. We have the measurement problem that hides the mechanism of collapse. We have dark matter and dark energy that hide themselves from direct detection. We have the Big Bang that hides the origin. We have consciousness that hides its own nature. We have fine-tuning that hides its explanation. We have space that might hide non-spatial reality. At every turn, when we dig deeper, when we ask fundamental questions, we run into walls, limits to knowledge, things we can't know, can't see, can't access. The universe is structured to keep secrets, and I think this is profound. It tells us something deep about the nature of reality. Reality is not transparent to observers within it. There are things about the universe that cannot be known from inside the universe. This connects to G. Fidel's incompleteness theorems. Any sufficiently powerful logical system has true statements that cannot be proven within the system. You need to step outside the system to see them. The universe might be like this. There are truths about the universe that cannot be discovered from within the universe. We're embedded in reality. And our embeddedness limits what we can know. The universe hides things from us because we're part of it, not separate observers looking in from outside. Does this mean we should give up? Stop asking questions. Number absolutely not. Understanding the limits of knowledge is itself knowledge. Knowing what we can't know is valuable. It tells us where to focus our efforts. It tells us what questions are answerable and what questions might be forever beyond us. And sometimes, understanding the limits helps us find creative ways around them. We can't see inside black holes, but we can study Hawking radiation. We can't measure position and momentum simultaneously, but we can use uncertainty relations to understand quantum behavior. The universe keeps secrets, but it also gives us clues. Physics is the art of reading those clues, of inferring what is hidden from what is visible. Every breakthrough in physics has been about seeing past the surface, understanding the hidden structure. Newton saw that the same force governs falling apples and orbiting planets. Einstein saw that space and time are not absolute but relative. Quantum mechanics revealed that determinism is an illusion. The holographic principle revealed that space might be emergent. Each of these insights came from recognizing that the universe was hiding something and figuring out what. The universe doesn't make it easy. It conceals, encrypts, limits, but it also leaves traces, patterns, mathematical structures that point to deeper truths, and that is what makes physics beautiful. We're detectives piecing together clues, reconstructing the crime scene of reality. So what doesn't the universe want you to know? Everything beyond your cosmic horizon. Everything inside black holes, the exact state of quantum systems, the mechanism of measurement, the nature of dark matter and dark energy, the origin of the universe, the reason for the arrow of time, the source of consciousness, the explanation for fine-tuning, the fundamental structure at the Planck scale, whether the universe is infinite, whether you have free will, these are the secrets. And recognizing them, understanding why they're hidden, that is one of the great achievements of modern physics. We've mapped the boundaries of knowledge, we've found the limits, and in doing so, we've learned something profound about reality. The universe is not fully knowable from within. There are built in limits to what observers like us can discover. The universe keeps secrets, and that is okay, because understanding the limits is itself a form of knowledge. Knowing what we can't know is wisdom. I've spent my career pushing against these limits, trying to see past them, trying to find the hidden structures. And what I've learned is that the universe is far stranger, far more subtle, far more mysterious than we ever imagined. The secrets it keeps are deep, and uncovering even a few of them, getting even a glimpse past the veil. That is what physics is all about.